Real quick, so the start of the video has it. Today's header, you should have on here, repeated addition is multiplication. That's all it is. So multiplication is made up. It's fake. A person invented it. But then again, a person probably invented addition. So multiplication is a shortcut, right? It's a strategy that helps us think through these situations. So I have the problems in the smartboard, but I want you guys to just take some time on your own or like as a group to interact with these problems. So after we talk about this real quick, I'm just going to give you a little bit of time to do 67, 68, 69, as much of that as you can on your own, probably pretty quickly. And then we'll move forward together. So, previous lessons, we've done lots of like, add this, add that, add a negative this, add a positive that, whatever. But if we sort things out and we have all the same size moves, right? We were talking about the slackliner or tightrope walkers or people that are making the same size moves. If we, let's say we're even like buying something, like I get a package of 7 and another package of 7 and another package of 7 and another package of 7. Or maybe you're getting paid $7 an hour, right? So I work an hour, I get $7. I work another hour, I get another 7. 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 But then I go to the store and I buy a sandwich for $5. 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 Who's annoyed?
So many sandwiches. Why do you have so many sandwiches?
I'm really hungry.
Yeah, why did you buy 5 sandwiches?
So
Why did you pay
instead,
Starving to death.
hey, bring it together. As always, I would love for you to have time to work on your homework today. Instead, we would count 1, 2, 3, 4. Ooh, oh, hey. 1, 2, 3, 4, 5, 6, 7, 8. And say, okay, 8 times 7, right? Because there were 8 7s there. And there's a lot of these. Right, so we would count the amount of them. And when we write that, sorry, now that I'm dragging screens back and forth, now I have to bring it back to where I can actually write on it. We write that appropriate, well, the most efficient. I guess I don't want to say appropriate, because there's multiple appropriate ways. You could write, this is going to make me hurt for a moment. Actually, I'm not going to worry about the plus. If we just look at those 8 7s and don't worry about the negative right now, we could write that, but you never again are going to. Because we now are looking at the x as a variable in upper level math. So we do not use it for multiplication. You could write this 8.7, and the only reason that's dangerous is if your dot's not quite high enough and it's like, wait, is that a decimal? Is that multiplication? So we could also, what is equally as good, in my opinion, probably actually even better, write it like that. And that says we have 8 7s. And that would come out to be 56. Right? Which I can figure out more quickly than 7 plus 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 1 more 7. So, oh yeah, I did have this up here. Oh, look at that. Good on me. So, if we do want to look at that, the negatives then, all right, Toby, thank you for volunteering. How many negative 5s do we have up there? 8, probably.
Yeah.
So then we would say, and 8 times, and here's why I think using the parentheses to multiply is better. What do we do with negative numbers? Put them in parentheses, right? At least a lot of times we put them in parentheses. So my parentheses here serve 2 purposes. It keeps the negative together, and it tells me we're multiplying. Please go ahead and write that on your paper, the 8 times 7 and the 8 times negative 5. And notice I said and. Well, that's the addition, right? 8 times 7 and 8 times negative 5. And is the addition. So when you say it out loud, you could say plus, or you could just say and. So then 8 times 7, we just said is 56. What's 8 times negative 5? Well, make your life easy. What's 8 times 5? 40. Now make it negative, because if there's just 1 negative, the answer stays negative. By the way, if you haven't taken time to just like space out and look around my room, there are lots of really useful cheat sheet type posters, like over here, where it talks about the multiplication and division or addition and subtraction rules. Also an ugly spot where they should have painted over, and I don't know why. I should probably complain to somebody. But then, when we group these together, like we did yesterday, who's stronger, good guy, bad guy? Good guy, by how much? By 16. I want you and your partner to take the next, let's say 5 minutes, and try to get as far as you can in the lesson. I will move this up here in a couple minutes, but right now just work on 67, 68, and I'll probably zoom in a tiny bit more for you too. Now remember, just like in your homework, we can move either direction. And directionally, we're going to use plus minus, right? Positive, negative. So, you have the lengths of 5 and 8. You can go forwards and backwards. You need to land a distance 6 feet away from where you started. Then in 68, re-represent that. And 69 is essentially the same thing. Re-represent that problem. So dive in, 67, 68, 69.
And it has to be 60. 8 times 5.
Yes.
So the homework that I've not turned into yet, which one of those?
So in math, the numbers are in there, so you can always check math. But let's check the these turned in. Chapter 1 looks good. So it would be 211, 212, and 221. The first 3 homeworks from chapter 2. Thank you, sir. That brings up a good point. Eric asking about homework. We will again be collecting homework on Thursday. So I would potentially, not guaranteeing I will, but tonight's homework could be collected Thursday, right? Because it's 2 days. It's that 2-day policy. So I haven't yet decided what all I'm collecting, and we might squeeze in a mini mastery before we reach the cutoff. But yeah, so please make sure you've got your homework done or come see me with questions. We'll probably check answers tomorrow.
Are you gonna?
Yeah, I know. I just need to update that. But you don't need that if you fill in your plan book when you come in.
Yeah, I know.
Yeah. I'm going to update that for anyone who's been sick or anything like that. You probably have half your time left. You should be done with at least these 3 problems when we're out of time. Look at how much time you have left.
That's the time I brush my teeth.
You brush your teeth for 5 minutes?
10 minus 16. Exact same time.
It's probably a 2-minute timer that you have on teeth.
Yeah,
I mean, that's good for you.
Problem with that there.
Hope you study math at the same time or something.
No.
Like just while you're trying to like
8 times 2, and then 10. I mean 5 times 2, and then subtract. Subtract what? Okay, so basically you have to use 5 and 8. What are you getting? Because 8 times 2, and then 5 times 2. Oh my god. Wait.
You should be asking your partner anything you're concerned about right now.
We have conflict.
Are you still on 67?
Yeah, we have conflict.
What do you mean you have a conflict?
When you're like doing it, are you allowed to multiply like the 5 by 2?
You can do a move of 5 and another move of 5. They said you can only use lengths, right? Moves of 5 and 8. So if we, want to give away one way here. When I see the numbers 8 and 5, and then the target of 6, my brain immediately looks at that 8 and says what? It can make 16. Right? So if I do 8 and 8, Then what should I do?
5 minus.
Yeah, -5 and -5. Which, if we want to represent in a more efficient manner, 2 moves of 8 and 2 moves of -5. Now wait, I'm going to blow your mind. We can be even more efficient. What if I did 2 times, like 2 moves of an 8 forward and a 5 backwards? What would I get if I went 8 forwards and 5 backwards? 3. Another 8 forwards, another 5 backwards, and 6. So this comes out to be 6. So do all of those. Now you were asked to do that in 2 different ways. But I think we can keep moving. So CPM really wanted me to give you time to engage with these alone, but I think we probably are all pretty good on the next couple problems. Did anyone come up with a different way to get to 6 using 8 and 5? There are other ways. What if I do 5, 5, 5, 5? What's that give me? 4 5s, 20, and then back 8, we have 12. Back 8 more, I'm at 4. I can figure this out. Forward, 5, back 8. I'm like, yeah, we just kind of play around with the numbers for a while. There are other ways to do this, and you can get really creative. All right, moving on. By the way, snacks and people that might maybe have sketch pads out or things like that, I'm okay with all of that as long as you're engaged with math when you need to be, right? So be able to pull it back. And sharing snacks, just be careful. Ask people if they've washed hands. We are getting into cold and flu season. Here, Cecil went 6 feet, 6 feet, 6 feet, 6 feet. Except this is my forward and that's his forward. How could we more efficiently say this, Morgan? So I'm going to start using cards to make sure people are awake. How could we more efficiently say what Cecil did up here? Yeah?
4 times.
Yeah. Ooh, you bring up a good point. This is what I was thinking in my brain, but this is what Morgan said. 6 foot moves 4 times. Is there any difference between those? No. So please write both of those on your paper. Whether I have 4 on the outside and 6 in the parentheses, or 6 on the outside and 4 in the parentheses, these will both equal 24. Sarah, what about this tightrope? How could we more efficiently say what he did here? Yeah. There we go. We could do 7 times 5. We could use the dot if we wanted, but we like the parentheses. Equals 35. Or likewise, we could do 5 moves of 7. And in my brain, it's not right versus wrong, but this is better because when we speak math, multiplication is said as of. So this would read 5 of 7, which is what we have. We have 5 of 7. This is the same, mathematically the same, but if you're trying to read it, this in my opinion, and that's just an opinion, right? It's not right or wrong. My opinion, that's better. Next.
Why are there 2 lines?
What do you mean, why are there 2 lines? These are the jumps. This is the tightrope going from A to B, and these are the jumps. This is Cecil moving.
But couldn't you just make it on the line?
Yeah, but then you'd have to show it with like boing, boing, something like that. Because you don't want to just draw on top of the line. I mean, you could, but it wouldn't look as nice. They did it to try to make it look nice and make it easy for you to see. All right, this one's a little bit different, right? So now we don't see a number line. When adding the same number several times, multiplication can help. Well, yeah, we've already established that. Thank you, textbook. So we're going to do this same pattern over and sorry, I don't like saying things over and over because we no longer believe in like rote practice, right? Just do this a bunch of times. But if we see 3 plus 3 plus 3 plus 3, we know that's really 4 of 3, right? So how would we rewrite in my opinion, the better way, this. How do we rewrite that? Callie? I'm just using cards now. The 2's. How would we rewrite that using my preferred method from like the last slide? Yeah. If you were with me on the last slide, it's okay that you weren't 100%. Yeah, 5 of 2. Right, so 2 times 5, what Callie said is right, but in my opinion, just for starting to visualize, we have 5 2's, right, is what we see. We have 5 2's. Now 2 times 5 will get you the same answer.
Yeah.
So it's not right versus wrong, it's just I'm kind of trying to brainwash you.
Okay, that's cool.
So, and here's why. The amount of moves, or the amount of things we have, is normally a whole number. I have 7 pizzas. I got 4 pairs of pants. I got 3 pairs of shoes. Right? Like, normally we're working in real quantities, but those things we're talking about, what did my pizzas cost? What did those pants cost? The shoes cost? Aren't normally whole numbers. They're often numbers that involve 2 decimal places, right? Not just 1. So that's why we like to say we have 3 of 6.2 and 2. So take a moment at your desk, solve what is this? Actually, when simplified, 3 of 6.2 and an extra 2. She's bored with what I'm covering. It's okay. We got to come back when we need to come back. I'm being honest. What?
Honesty.
I'm not judging. I said it was okay that she was doing that. That's not judging. But now she has to do this, and then she can go back to that. If you don't need the amount of time I give, once you're done doing this on your paper, it's okay if you do like 1 or 2 homework problems. Like of those little like quick ones, it's okay. Like that was, I know some of you that were further away didn't quite understand what was happening. That was the little thing up here was like, you're not supposed to be doing your homework. Well, actually, it's okay, kind of like in this moment do this, but then you can go back to your homework. I highly advise that we draw arrows anytime we're multiplying into something that has multiple numbers, like multiple digits. Right? So 3 times 6 is what? 18. 3 times 2 is 6. But, so here's my trick for multiplication. Give me eyes up here, because I think a lot of you have been like taught the algorithm, but here's the easier way to do it, right? I'm trying to make your life easy. Forget about decimal places while you're doing the actual multiplication. Then once you get your answer, like 3 times 2, how many decimal places out is it tells you how many you need. So I need 1 decimal place in my answer because I only have 1 decimal place between these 2 numbers. Because this is out in the ones place, it's not in the decimal places. 10th place of this needs to be 10th place. So that gives me 18.6 and 2 more for a total of 20 and 6 tenths. Right? Any questions on that one?
What's
8 times 7, 56. 5, 6 equals 7 times 8. 5, 6, 7, 8. 5, 6 equals 7 times 8. How would we represent this in that preferred way? Savannah?
You could do negative 5 of negative 3.
Yeah, 5 of negative 3. Here's the other reason why we like to do it like that. The other way to do the multiplication, negative 3 times 5, we shouldn't leave this not in parentheses. Because this is not subtraction. There's nothing to subtract from. So we would want to put that in parentheses. And if pretty much the same.
Wait, wouldn't the 5 have to get left?
Doesn't have to be. This is the same as this. That's actually a really good point, Nick.
Okay.
Any number against a parentheses or variable, regardless of whether it's on the left side or the right side, both of these are the same.
Okay, that's cool.
So please put your eyes on that for a moment and make sure you're aware. If it comes after the parentheses, it still multiplies. So that might be like, yeah, well, I'm working with -3. Oh, yeah, and I have 5 of them. Just by the way. Like you forgot. You realized that after. Questions? I think this lesson is a bit more attainable. Man, 77. I was trying to remember what problem was on the blue sheet. So, and I'm not making you write down everything. Up here, do we understand how if they present to you a diagram of like pluses, right, those positives that we've been working with, and they've got them grouped, this diagram has, oh, we haven't worked with these yet, but we will. We have little plus minus tiles. Didn't we do that yesterday? Am I crazy? Okay, you weren't here. So, it's on the video if you want to see it, because I did my whole dot cam thing and everything. Yeah.
Can I wash my hand? I have cheese.
Oh yeah, you're good. I understand the cheese. Like, yes.
Where-
That, we could say, is 2 groups of +3. Right? We could do the same with negatives. Right? So think back to yesterday with those pluses and minuses. So then, what would Chad draw to represent this? Take a moment and try that on your paper, on your graph paper. Right? How would Chad draw that? If this shows us 2 groups of 3, and we're asked to draw a diagram to represent that, how would we do it? Anyone bold enough that you want to come up and try it? Yeah, really. Come on. Especially since you're alone. You guys really make me hungry during this first period. Stop it.
Sorry.
Oh, really?
I just have like much to say.
All of you, like multiple things.
I'm not hungry. Mr. Hudson, did you hear they changed the zodiac?
Okay, that doesn't pertain to what we're doing right now. You're touching with your hand and the pen. It's okay. That's what happened. That's why all those dots are there. So notice Lily is making groups of 3 negatives, and she's making 5 of them. Or she has made 5 of them. Cool? All right. Thank you. You can just set that there. My people sketching, please make sure that you're really comfortable with this. So I think we're probably good with 74. This is one of those lessons where I kind of skip around a little bit. When we look at, actually I would like everybody with me again, so if you're sketching, put a pause on that. This expression, 2 times 3 plus 5. Go ahead and write this in your paper. 2 times 3 plus 5. We want to talk about something that is just now becoming an issue. How we say math, right? How we tell somebody what we're doing. This can be said 2 times 3 plus 5, or 2 times 3 plus 5, and they mean 2 totally different things. Because 2 times 3 plus 5 is this. 2 times 3 plus 5 is this. It's all about where you pause, right? So because of that, we use the word, and you might want to write this in your notes. If I was you, I would need to. Quantity. Quantity is how we indicate that things are grouped together. So here, we would say 2 times the quantity of 3 and 5. So if you were listening to somebody say math and they said 2 times 3 plus 5, you're not quite sure, is it that or that? Right? But if they say 2 times the quantity of 3 plus 5, you know that's a group, it's a quantity. But well, can't we do 3 plus 5? Yeah, that's 8. What's 2 times 8? 16. The other way we could get there is distribution. 2 times 3 is 6. 2 times 5 is 10. And you are technically allowed to do that, but the better the following PEMDAS would tell us do the addition first. So if we're following PEMDAS, because it's in the parentheses, it would tell us to do that first. However, this is the same, so I just wanted to show another distribution that they come out to be the same.
Don't you always have to follow them no matter what?
Yes, but why I showed this is if this was x plus 5, you could not add them. And that's where we would have to distribute. So I'm just trying to make sure that we've seen that a little bit. We're not going to draw a diagram to represent this because I don't like making you draw partial diagrams. Please make sure, so eyes up here, please. Especially I got like 2 people that I'm talking directly to you that I'm worried that every time I look back we're sketching. This, right? The biggest thing I want you to know, and I don't want to make you draw it, is if we were asked to do this like, I don't know, on a mastery, this means 3 moves in the negative direction 2.5. Right? So it'd be 2.5 negative, 2.5 negative, 2.5 negative, and then another negative 4. So this representation, and you don't have to draw it on your paper, but I'm going to draw it up here real quick. These would all be 2.5s. This is way too thick. And then a negative move of 4. This is different. That would be 3 copies of a negative 2.5 and a negative 4. So that would actually be negative 2.5, negative 4. Both moves, and then we would copy that. Negative 2.5, negative 4. Is anybody confused at what I mean by when we represent this? Because then we would do it one more time, negative 2.5 and negative 4. Now it comes out to be the same though. Right? It comes out to be the same. I'm trying to get to 77 because I know it's on your blue sheet and I wanted us to do it. What? Maybe I'm crazy. Aha, I just didn't get to copy it there. So check out 77 on your blue sheet. The reason that we looked at that distribution, and Nick was a little upset that we were looking at distributing it, is because sometimes it's just easier that way. So give me just a second, so I want to copy this so I can actually write on it and get it in the video. I thought I had it in my slides, but Mrs. Goldring needed some tech help this morning. Go figure. So 7 times a negative 105. Or really, honestly, guys, any triple digit numbers make me nervous when we come to multiplying. So we're on our blue sheet now, and I should have everybody's attention, pencils in hands, looking at their blue sheet. 7 times negative 105 is not as easy to think through as 7 times 100 and a 7 times 5. So we break this apart. Right? That's one of the big ideas that has been like huge in Common Core that wasn't really a big idea before because there was this weird mentality of like, just do it how it is. And like, well, that's not the most efficient way. Can we do 7 times 100 pretty easy? Yeah, we get negative 700 when we put that negative back on. And when we do 7 times 5, we get 35. Negative when I put it back on, right? So then I just put those numbers together. Use that strategy down here to solve these problems. Obviously, D is the toughest. So take like 3 to 4 minutes, solve these 4 problems. My advice is use the broken up strategy. Now 6 times 12, you might know that, but you could break up 12. You could break up 12 to 10 and 2 if you want. So we're doing these on your blue sheet. I will expect that it will be done when I check your homework. Oh, yeah. I appreciate it. When we do it together, talk with your partners. That's also how you check it. You can use a calculator, but the strategy idea here would be you don't need the strategy idea here would be you don't need to. Now I have to hate this. You made that choice because you're not doing what you're supposed to be doing, so talk to me after class. If you don't know 6 times 12, do 6 times 10 and 6 times 2. Oh, there's always multiple ways. Never think that the way I write up here is the only way. For the sake of time, I'm going to start going over these, but you can keep working on your own if you want. I've got some people desperately wanting to check what they got. If I break up 12, now some of you might know your dozens, right? Like 6 dozens would be 72. But if you don't know that and I break up my 12, 6 times 10, 60. 6 times 2 gives me another 12, so I've got 60 plus 12. All right? What's that?
You have to do the what's in parentheses.
You do not. So the strategy we're practicing here, and this, you totally stopped paying attention because you were doing your own work back there, right? Let's just be honest, right? You were doing your own thing back there. You weren't paying attention the last couple slides when we talked about why we do this strategy. We could do 3 plus 5 here, get 8, and then do 2 times 8. But also, we will get the same answer if we do 2 times 3 and then 2 times 5. 6 and 10, and we get 16. So yes, if we are directly following the order of operations, we do the parentheses first. But once we start working with variables, we won't be able to. We can't do in the parentheses there. So we need to get comfortable now that the distributive property lets us represent a somewhat difficult number, like a value of 105, broken up, and I can do the math separately. So, Araya, I think this needs to be a learning experience of if I'm talking, you shouldn't be doing your own work, not paying attention. Right? So I know we're all getting used to like how attentive do we need to be in class and like how things roll, but like there are things you don't know. Right, in every classroom you're going to go into, and I've seen each and every one of you look like you don't need to pay attention. Right? I've observed it when I'm not even teaching and I'm looking across the pod and people are staring at the ceiling counting dots. You've got a lot to learn, right? We're here to teach you. So that's why we're doing this strategy, all right, just to make things easier. Now, if I have a calculator or if I'm really good at math, sure, add the numbers up and then do the multiplication. And I get it in A, that would still be kind of easy, right? Because that'd be 6 times 8. We're just practicing a strategy. Right? So this would be 72 plus this multiplication. What's 6 times 4? 24, and then we know it's actually negative. So it'll be plus negative 24. And then we could put those together and get the same thing that Araya got. What'd you get when you did 6 times 8? There you go. That's what this will be also. Now, what would have actually been easier is if I left my 60 separated from my 12. In my opinion, it would have actually been easier to do 60 plus 12 plus negative 24, because I would have put the 24 with the 60, because it would have been easier. So, Array, if I asked you to do 7 times 310, or 7 times 290, that actually seems more scary. Both of those are pretty difficult. But if I asked you to do 7 times 300, that's not that scary, because it's only 7 times 3, and then a couple zeros. So this is actually 7 times 290. But, like, yeah, because 300 plus negative 10, right? If we do parentheses first, but I don't want to do that. Toby, do you know 7 times 29? I don't know 7 times. Yeah, I don't know 7 times 29. Eric, do you know 7 times 29? No. Does anyone know 7 times 29 without a calculator? Drop it. No! Right, but who knows 7 times 3? I hope we all know 7 times 3. So this, 21, and then 2 zeros. So 2 zeros. Eric?
By the way, 7 times 290 is 2030.
Well, that's fine, but use the calculator. So poo-poo you for not doing that.
What? I don't know what you're talking about.
7 times 1, 7. Then put the 0 on, and then put the negative on. So now we have 2100 and a negative 70. So take that 70 off. 2030. Questions on B?
I'm going to copy the schedule.
What was that, bud? You will. There will be instances where you have, like, it's unavoidable. So as we get up into algebra, you'll have to use the distributive property. If it asks you to, then yes, because we're practicing a skill with things you already know how to do, so that when you get to doing the stuff that you don't yet know how to do, it'll be easier. Class, what's 4 times 3? 12. How many zeros do I put on? 2. What's 4 times 2? Oh, well, that just made this a whole lot easier. 1208. What? Now let's see if we can do it without writing the whole thing out. 3 arrows. What is 5 times 8? 4D. Right? 40 already. And then how many more zeros? 2 more zeros. That was the 5 times 800. Right? That was that. 40, then 2 extra zeros. What's 5 times 7? 35. How many more zeros? 1. That's your 5 times 70. 5 times 1? And we just leave it. So, well, okay, 35 and 5. 40, 40. There we go. And until that wall opens, I would do your homework. I think that should really become like our everyday policy. Just use this time to get as much done on your practice work until they open the wall and say they're ready for us. Probably did. The chances are I did. So, yeah, Araya caught, and apparently so did a lot of people, but you didn't speak up. That should have another 0. Because that's 70, right? 5 times 7, then the extra 0. So this should be 4,355. Good, you should have spoken up then when I made a mistake. Don't let your friends make mistakes. And I hope we're friends. Don't let me make a mistake. Welcome to Phoenix. We respect you.
People always get in
Whoa.
Don't correct the teacher.
No, do correct. the teacher. Hooray, you get a piece of candy because you corrected the teacher. Look at that. Learn to correct the teacher.
That's weird because I just thought the deal